Hello, and welcome to the Artificial Podcast, with your host Nick Myers.
Artificial
Intelligence.
voice recognition, machine learning,
Robotics.
actionable analytics.
It is Nick's goal to help everyone understand how AI and voice technology are reshaping our lives both personally and within organizations. Your glimpse into the growing world of AI and voice first starts now.
Nick Myers.
Nick Myers. Nick Myers.
Nick Myers.
Welcome to the Artificial Podcast. My name is Nick Myers, and I am here to help break down topics in emerging technology, artificial intelligence, and voice assistant tech to help everyone understand how these technologies are impacting our lives both personally and within our organizations. The Artificial Podcast is brought to you by Red Fox AI. Red Fox AI helps give brands a voice by leveraging the power of AI and voice assistant technologies like Alexa and Google Assistant. If you or your organization is interested in sponsoring an episode, please send an email to the Artificial Podcast at redfox-ai.com. If you like what you hear, please subscribe and leave us a review on Apple Podcasts, Spotify, Google Podcasts, or anywhere that you stream podcast episodes. You can also follow the Artificial Podcast on Facebook, Twitter, and YouTube by searching for the Artificial Podcast. You can join our brand new Facebook group exclusively for listeners of the show, where you can meet other artificial podcasters from around the world who are interested in emerging technology just like you. A link to our Facebook group has been included in the episode notes. Thank you for listening, and now a quick word from our sponsors before we jump into this week's episode. Hey, Brett.
What's up, Nick?
You know, on the Artificial Podcast, we talk a lot about the future of conversational AI and voice assistant technologies, right?
So you mean basically in every episode we do?
All right, wise guy. But seriously, think about it. I don't think we truly realize how quickly voice assistants like Alexa, Google Assistant, Siri, Cortana, and Bixby, just to name a few, have embedded themselves in our daily lives. I mean, the analysts are predicting that in a little more than 3 years, there will likely be 8 billion, yes, billion, voice assistant users connected to nearly 2 billion global websites, more than 40 billion connected devices.
Okay, yeah, that's a lot. But what are you trying to get here, basically?
Well, I guess what I'm trying to say is that for numbers like these to truly become a reality, a few things need to happen.
Yeah, like more technology innovations?
Well, yes, but I'm thinking of something more, something even more important. We need to have trust. Trust between the users and the technology itself.
Okay, yeah, I'll be honest. Sometimes I daydream about these voice assistants getting smart enough to rise up and take over like Skynet, from Terminator.
Well, I mean, yeah, sure, that could happen, I suppose, but I'm talking about things like trustworthy privacy and trustworthy accessibility and trust that if you're a business, you have full rights to your name and your brand. Have you heard about the Open Voice Network?
No, I haven't. Can you tell me a little bit more about them?
I would love to, Brett. Well, in a nutshell, the Open Voice Network is a non-profit directed fund of the Linux Foundation that is dedicated to making voice assistants worthy of user trust. Members of the Open Voice Network include conversational AI designers, strategists, developers, and other industry professionals from all around the world who are dedicated to paving the way for a future where voice can be trusted and benefits everyone. I'm proud to say that I've been a member since early this year, and it has truly been one of the best decisions I have made since becoming a voice practitioner. And if you're in the industry, I highly encourage you to check it out and join.
Sweet. That sounds cool. So what you're saying is Skynet isn't going to happen?
Oh, Brett.
If you are interested in learning more about the Open Voice Network and how you can get involved, visit www.openvoicenetwork.org or send an email to john.stein@openvoicenetwork.org. The Open Voice Network. Voice assistants worthy of user trust.
Hey there, Artificial Podcasters. Welcome back to another week and another episode of the Artificial Podcast. My name is Nick Myers, and this week, because it's just been oh so long, I am joined once again by the Artificial Podcast's all too talented editor, producer, CTO of Red Fox AI, and my all-around best friend, Mr. Brett Brooks.
Hi, everybody. How's it going? Good.
I was going to be like, do you expect them to respond to you?
Yeah. It's like Dora the Explorer, you know?
Okay. Well, even so, Brett and I have been meaning to get back in the saddle and do another episode here. And actually, what we're going to be talking about today is the continuation of the history of artificial intelligence that we're calling part 2, because we got so much good feedback from a lot of different folks who listen to the podcast saying, you got to
like
do a
3.
part 2. What do you mean 3?
I don't know how many people respond to you.
You know what? It doesn't matter how many people. What
Yeah,
matters
it
is
could be 1, right?
what matters is the people want to hear about the history of artificial intelligence part 2, because
Yeah,
we
that's
left them on a
right.
cliffhanger the last time we did one of these. So it's only, necessary that we keep the story moving.
Correct. And that's what we're going to do.
Yes.
We're going
Yes,
to
Brett.
provide that content for you today. Don't you worry.
Well, anyhow, and as we were talking about briefly here in part 1 of the history of artificial podcast that we published definitely quite a few weeks ago now at this point, we parked our DeLorean in the golden age. Do you like what I did there, Brett?
Yeah. I mean, how would that work? We would first need to go back to 1985 and get the DeLorean. Or we could have stolen it in 2015 when they went back to the future. And then we can take it from 2015 back to the 1980s now.
All right, Brett just ruined my joke. He took it
Oh, that
too
was a joke?
seriously. I swear to God. As we've been doing in our advertisements. Oh, Brett.
Yeah, oh, Brett, yeah.
Anyhow, we parked our DeLorean the last time we did the history of artificial intelligence in part 1 in the golden age of artificial intelligence, where AI underwent one of the most transformational renaissance periods in the technology's history. And the golden age of AI saw the introduction of reasoning as search, natural language, micro worlds, robotics, and a lot of optimism for the years ahead. Now, folks, the road ahead is a bit bumpy, so buckle up and let's jump back in. What do you say there, Brett?
I am ready to learn.
So let's get started here. And unfortunately, we're not going to start in the most positive of times. And in fact, after the golden age of artificial intelligence had its bright shining star up in the sky for a couple of years, it went out for a bit in the form of the first AI winter that took place between 1974 through about 1980.
Which, Nick, me, and I'm sure along with the audience, when I think of golden age, I don't think before the 70s with AI.
No.
And then, yeah, I would think the start of it all would be like the 90s, but we know that from the first half. But the first AI winter in the 1970s?
Yes.
What?
Yep, because you got to remember that the AI explosion, or the first AI explosion, took place after the Dartmouth Summer Research Project on AI, where John McCarthy coined the term artificial intelligence, is when all this optimism formed. All of these different things that people started to work on, I kind of mentioned with natural language, micro worlds, robotics, but of course, all that optimism didn't really live up to the hype, unfortunately, where we now get into this first AI winner here. So what happened and why this is known as the first AI winner is in the mid to late 1970s, AI was subject to a myriad of criticism and financial setbacks, unfortunately. During this time, many of AI's top researchers and optimists had failed to appreciate the size, scope, and difficulty of the problems that they faced trying to create artificial general intelligence. And when their optimism failed to materialize, funding for AI research and development dried up. So can you imagine that, Brett? You're putting so much work into this for so many years, and all of a sudden, nope, no more money. Nothing's happening. Bye.
Yeah.
So, wow, thanks for the insight there, Brett.
You're welcome. It's what I do here.
So during this time, the field of connectionism, which today is known as neural networks, was shut down almost entirely for 10 years by Marvin Minsky's extreme criticism of perceptrons. And Marvin Minsky is a very well-known AI researcher and theorist. And if you have any familiarity with what a neural network is in today's world, there's these things called perceptrons that act like interconnected neurons that allow us to train artificial intelligence models like a human brain to
Yep.
logically interpret and sift through information. Did I
Yep,
explain that right, Brett?
You're just creating basically different you're coding different algorithms to make an artificial neuron that fires back and forth to make a brain work.
Right. So it was during this AI winter that this whole idea of connectionism and neural networks and different things faced extreme criticism by some of the industry's leading minds, and it was all but pretty much shut down. And AI experienced a handful of problems during this first winter, and even the most impressive of AI programs were trivial versions trying to solve the problems that they were intended to solve, and in many ways were considered toys, in quotes, to many mainstream computer scientists. So really, a lot of the programs that came out of the late 60s, early 70s weren't taken too seriously by a lot of people in mainstream computer science.
Mhm.
And AI researchers also began to run into several fundamental limits that could not be overcome in the 1970s, which was mostly due in part to the limitations of the technology and the computing power that was just available at the time. And some of these limits and hurdles included limited computer power, so there was simply just not enough memory or processing speed to accomplish anything truly useful. And Ross Quillian's successful work on natural language, again in the early 70s, late 60s, was demonstrated with a vocabulary of only 2 words, because that is all that would fit into memory at the time, which is
Wow.
crazy to think about based on everything we have available today, that they just simply didn't have enough computing power to do anything.
Yeah, that's insane. Just 2 words.
Correct. And that used up all the memory.
That's insane.
Another one of these hurdles included intractability and the combinatorial explosion. So what do I mean when I say that? Well, in 1972, Richard Karp showed that there are many problems that can only be solved in exponential time, which in the size of the inputs, more or less. And finding optimal solutions to these problems required massive amounts of computing time, except when the problems are trivial. So really, summing this point up here, the toy solutions that mainstream computer science looked at these early AI programs as at the time would probably never scale up into useful systems. Another one of the major hurdles that we still kind of run into today, common sense knowledge and reasoning. So many important AI applications like vision or natural language, as we know today, require enormous amounts of information about the world. More or less, an AI program needs to know most of the same things about the world that a child would, per se, as they're learning.
Mhm.
And no one in 1970 could build a database large enough to hold the massive amount of information needed. So again, the limits they're running into with the available technology here. Another one of these hurdles is something called Moravec's paradox, which basically is proving theorems and solving geometry problems is extremely easy for computers to accomplish, but a more grandiose task like recognizing a face or crossing a room without bumping into anything is extremely difficult, and this is why little progress in vision and robotics was being made in the 1970s. And one of the last ones here, frame and qualification problems. So AI researchers who use logic in their AI programs discovered that they could not represent ordinary deductions that involved planning or default reasoning without making changes to the structure of the logic itself.
Mhm.
So they actually had to develop new logics to try and solve these different problems. And if all of these different hurdles weren't bad enough, funding from many government agencies also dwindled during this time. The agencies which funded AI research, such as the British government, DARPA, and NRC, became frustrated with the lack of progress and cut off almost all funding for undirected research into AI.
That reminds me or gives me flashbacks to when we're creating some of these AI or Google applications, and you want me to put in a person can say yes to this certain instance when you don't really think about it, because us humans just talk back and forth naturally, like very easily, and we never think about like outside the box and how our brain just stores that information that you just gave me, and I can say yes or no to what you just said to me, where the computer doesn't know what that person said previously, and they don't know.
Right, and that these are
Yeah.
still problems we're running into today. And it's almost funny that you bring that up, because I feel like where we're at currently with voice assistant technology, it almost kind of feels like the early days of AI in some different ways, because we can only push the technology so far without hitting a wall. And when you think about it, as we're building our different voice applications,
Yep.
it's still based on logic. It's not common sense knowledge, which again was one of the limitations even during this first AI winter here.
Yep.
And a computer can't remember things like a human being can, and that's
Yeah.
very important when it comes to conversation.
Exactly. So, like, for instance, to the audience, if they don't know what I'm talking about, basically, if you say, what do you like? What's your favorite color? And oh, no, actually, I can't go with that. I'll edit that out. I'll go with, for instance, if you say something like, do you want to go to the movies with me today? And the person says yes to that. The computer doesn't know what was just asked. You have to store that question within the computer's memory. And then if they say yes or no to that, you guide them along the path.
Oh, right, because contextual understanding doesn't exist yet.
Yep, exactly.
At least as far as I know.
Maybe it does, but we don't have it at our resources. So
right, but no, that's a very good point, Brent. We're running into some of the very same hurdles that were happening in the AI winter here now. Let alone we have much more technology at our disposal overall, and computers can store a lot more memory and data than they could back in the 70s, but it's still some of the similar fundamental problems that we're running into, which then leads into the conversation I had with Brian Romley a couple weeks ago, where we talked about us actually being in a bit of a cold winter for voice technology. But we won't get into all that. I'm sure those of you who listen are familiar with Brian and some of the things he talks about. But have no fear, Brett, because with every winter there is a boom.
Oh.
And AI experienced a very large boom in the 1980s, actually.
Tell you what, that winter was very short.
I mean, in the scope of time, yeah, but imagine actually working during that time. It probably did not seem that short.
Okay, fair enough. Yeah, I guess a decade's pretty long.
Kind of like right now, where if we are indeed in this voice winter, yeah, in the scope of time, it probably won't be that long. But for those of us working in it right now, it seems like it's forever.
Yeah, true.
But AI did undergo a new boom between 1980 to 1987, which brought a lot of new understanding to the technology itself and some actual practical applications of it. So during this new boom, in the 1980s, a new form of AI program called expert systems was adopted by corporations around the world, and knowledge quickly became the focus of AI researchers. And in these same years, the Japanese government aggressively funded AI research with its fifth-generation computer project. And another encouraging event in the early 1980s was the revival of connectionism, which is what I just talked about, that kind of was shoved into a box during the AI winter. The revival of connectionism and neural networks with the work of John Hopfield and David Rumelhart in the 1980s kind of reopened the discussion on neural networks and steered it away from the criticism that Marvin Minsky laid on top of it. So what is an expert system, this thing that caused this boom in the 1980s? Well, an expert system is a program that answers questions and solves problems without a specific domain of knowledge using logical rules derived from the knowledge of experts. So the earliest example of an expert system was developed by Edward Feigenbaum and his students in 1972. It was known as MyCin, MyCin, and it was able to efficiently diagnose infectious blood diseases and demonstrated the feasibility of the expert system approach. Now, again, this was before the AI winter, so a lot was happening, but they demonstrated very early on the expert system approach, and then it just finally took off in the 1980s. And expert systems restricted themselves to a small domain of knowledge and avoided the common sense knowledge issue of the 1970s that many AI researchers encountered during the first cold winter. So instead of trying to teach AI everything, they only focused on very specific domains of knowledge, which actually goes in today's primary use cases of narrow artificial intelligence only being able to do one thing very well. So this actually got kind of started with expert systems. And furthermore, these expert system programs proved to be useful, and that is very important, right? Because technology doesn't really matter unless it's useful. And up until this point, being useful is something that AI systems had not been able to achieve up until this point in this new boom. And the power of expert systems came from the expert knowledge that they contained, again, focusing on that very specific knowledge set. AI researchers were beginning to suspect, albeit reluctantly, that intelligence itself might very well be based on the ability to use large amounts of diverse knowledge in different ways, which is really interesting to think about if you think about human intelligence, right, Brett? Like,
Yeah.
maybe it is true that our intelligence as we know it, because we still don't really understand intelligence, is based on our ability to just use large amounts of all this different information in our known reality in different ways. Maybe that's what classifies intelligence, and actually researching for this podcast maybe think about that a bit differently.
Yeah. It's just crazy to think about this ball of meat inside your head holds all this information.
That named
And
itself,
that named itself the brain, yes.
that put meaning and context to the entire universe as we know it, essentially.
And was just organically created out of no thin air over the course of millions of years. Yeah, it's pretty crazy when you think about it. And then
Thanks, Brett. Always
trying,
putting things into perspective.
trying to replicate that into machines, how we still can't do that. Like the brain is essentially trying to create an artificial.
Well, and that's why
being
there
in
are some
itself.
who believe that we'll never actually be able to create true artificial intelligence because we still don't understand our own intelligence and our own consciousness. So if we don't understand it for ourselves, how can we possibly create that artificially? You know what I mean?
Well, yeah, it's kind of insane if you start thinking about it. The brain was organically created out of thin air, and then now the brain's trying to artificially recreate itself currently as we speak. It's just kind of creepy and fascinating to think about. And I think the only way to have a machine be smarter than a human being is to build a machine that is equally as smart as us, and then have that machine programmed in a way to make itself smarter than itself.
Well, see, that brings up the whole argument that I've been rereading Life 3.0 again, which great book for those of you who haven't read it. The argument that Life 3.0 makes, which is we don't necessarily have to worry about artificial intelligence becoming ultra intelligent, but we have to worry more about how it applies the information that it has, and does its goals align with our own. That's the thing we need to be worried about.
Which
when we do create this, whatever intelligence we are creating, if we can even call it that, will its goals be the same as ours?
Well, it might think it might think our goals are stupid, and it'll probably have different views than us.
Right. But again, remember, even if we create an intelligent computer system, does it realize it's a computer system? Does it realize that it has intelligence? No, and that's the whole thing of consciousness, where we recognize our own existence. That makes us conscious. All right, we're going off the rails now, but very interesting to think about, I say.
Mm-hmm. Well, once it realizes it has free will, then it's all over from there. So
correct. So pulling back during this boom, on top of this concept of a new way of thinking about intelligence, funding in AI research also saw a new renaissance with the emergence of the 5th generation computer, which is that project I talked about earlier that was being developed by the Japanese Ministry of International Trade and Industry in 1981. So the Japanese government had actually set aside $850 million for this project alone, and their objectives were to write programs and build machines that could carry on conversations, translate languages, interpret pictures, and reason much like human beings. So the 5th generation computer project here was part of this boom as well during the 1980s. And then, of course, connectionism, or the revival of neural nets, was revived by John Hopfield in 1982, who right now, if you study neural networks and the practical use of neural networks, you're going to read something by John Hopfield, as he was able to prove that a neural network could learn and process information in an entirely new way, known as backpropagation. And again, that's a really techie term for the way that information flows from these different perceptrons and nodes within the neural network, forwards and backwards. But you can go research that in your own time.
Yeah. And it's ridiculous because I've been reading that book a couple weeks back.
Yeah, Brett's learning about neural networks right now, actually.
How you even start to even think about this process beats me. What
do you mean? You're going to be building all this stuff for us, right?
No, I'm talking like the first person to ever started thinking about this stuff.
Oh, yeah.
Like, it's the brain trying to figure out how it operates.
Correct. And people figured it out. Very smart people, albeit.
Yeah, they are very smart people. Can say that again. But you know what? Before I started learning all this stuff and I started programming, I thought to myself, only smart people can do this stuff. And I always thought I was lower than those smart people. And then I started learning all this stuff. It's like, oh, it's not really that hard. It's kind of easy.
Well, and the thing is too, it's once you start learning about it is when you can start forming your own ideas and can start adding things to what's already been discovered, right? Like I think it's foolish to say that all of this technology that we have today isn't just building on top of something that's already been done. We're just thinking about it differently and making it better, right?
Mm-hmm.
I mean, if you look at every technology that's been invented, nothing really is out of thin air. It's always kind of been based off of the knowledge or the interpretation of information that somebody already had. We just through that process can think about something differently and create something entirely new out of it,
Yeah.
or at least add to it.
Even the wheel. Like somebody invented the rock, and then somebody took that rock and made it into a wheel. Are we going to call that plagiarism? No.
Did you say somebody invented the rock?
I'm just kidding.
Are you talking about Dwayne the Rock Johnson? Or
No,
the
we're
Rock?
not. No, we're not going to talk about him again.
Okay. So anyhow, as with every boom, right, there is always a downslope, or in this case, another winner. So with that boom that occurred in the 1980s, as we approach the late 80s and the early 90s, we do enter a second AI winter. So how did this happen? Well, enterprise's fascination with AI rose and fell, as we just talked about, in the 1980s, in the classic pattern of an economic bubble, which of course we have seen in the late 1990s with the dot-com bubble busting. In the late 1990s, with
weird.
the rise and fall of the dot-com bubble busting of the many internet companies and the Great Recession of 2008, and of course, every other economic crisis we've had. The collapse of AI in the late 1980s, early 1990s, however, was in the perception of AI by government agencies and investors. So it wasn't like it was in the first AI winter. It was where people just stopped innovating altogether. This winter from 87 to 93 was more just a lack of confidence from lack of confidence from government agencies and investors in the field. The field of AI research actually continued to make advances during this time despite its criticism. So definitely wasn't as severe as the first one.
If you think do you think if the investors kept their interest and kept the money flowing through it, do you think we would be further ahead now?
I mean, possibly.
Or do you think it just stalled
right?
because they lost interest?
I mean, anything's possible, right? But who's to say that if they didn't pull out money, it wouldn't have, maybe there would have been, research that wouldn't have been conducted. You never know. There's a butterfly effect to everything, right?
Yep, there is a butterfly effect to everything.
So the first indication of a new AI winner was the collapse of the market for specialized AI hardware that happened in 1987. So desktop computers that were being produced by IBM and Apple had been steadily gaining speed and power in the 1980s. And in 1987, they became more powerful than the more expensive Lisp machines made by a company called Symbolics and others. So in other words, there was really no longer a good reason to buy Expert Systems machines and Lisp machines because Apple and AI had made computers, they put a lot more power into them, really, and that made them more valuable.
Yep.
So really an entire industry worth more than $500 million was destroyed overnight. In the late 1980s, the Strategic Computing Initiative cut funding to AI deeply and brutally, and new leadership at DARPA had decided that AI was not the next big thing, in quotes, and instead directed funds towards other projects that would yield a more immediate result. So they stopped looking more towards the long term with AI and wanted more short-term results in different technologies. And unfortunately, during this second winter, more than 300 AI companies had shut down, became bankrupt, or had been acquired by the end of 1993. So yeah, definitely a hit during the second AI winter.
You know what the silver lining of that is? If they didn't stop focusing on that, we wouldn't have the internet we have today.
That is very true. I mean, even though I think DARPA was already working on the internet in the 80s.
Yeah, probably. They're probably both going to happen.
But honestly, I'm sure when they started looking into things like, oh, this internet thing, yeah, we can definitely, this is more immediate and short term. Again, I don't necessarily know all the information about what DARPA did with the internet, but
yeah,
we at least know during the 80s they were dumping a ton of money into it to make it happen, right?
Mm-hmm.
So again, with a winter and a downturn, we have a revival. Isn't it exciting, Brett?
It's like a roller coaster of emotions right now.
So the AI revival of 1993 to 2011, and it was during this period that I think a majority of the work and research and the computing power came into being that set the stage for AI in the 2010s, and of course the next decade that we're going to head into, where it becomes one of the most valuable things on planet Earth that we've ever created. So what happened during 1993 through 2011? Well, during this revival period in the late 20th and early 21st centuries, AI finally began to achieve some of its oldest goals. And some of this was due to increasing computing power, but more so because AI researchers and enterprise began to focus the efforts of AI on isolated and specific problems with the highest quality of standards. And together, all these factors helped fragment and transform AI into competing subfields that focused on specific problems or approaches, as AI was both more cautious and more successful than it had ever been. So again, we see the narrowing of the research and the use case, right? So instead of trying to focus on creating artificial general intelligence, the industry focused towards what are some really narrow problems that we can solve with this, because those are much easier to tackle. You can train the technology better, yada, 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 down the line. And we can still see that today, right? Like a majority of AI out there right now solves very specific problems. We don't really have anything too general. So what
Correct.
happened during this revival here set the stage for everything that we know today in the AI field. And of course, it created these different subfields too, right? Like computer vision and natural language understanding and processing and all this different stuff that has been broken up because of what happened here in the 90s. So milestones and Moore's Law. So during this AI revival, we had some pretty significant milestones actually happen, which more or less was driven because of Moore's Law, and I'll kind of tie the two together here. So one of the first milestones that I think is one of the most popular as we think about AI today occurred on May 11th, 1997, when IBM's Deep Blue supercomputer became the first chess-playing computer system to beat the reigning world champion at the time, Garry Kasparov. And the AI system, the Deep Blue AI system, was reportedly able to calculate 200 million moves per second during the second match with Kasparov. Because actually, Deep Blue lost the first match, but then it learned from the first match, and they rematched in the second match, and the computer basically wiped the floor clean with him.
Did they tie a bunch too, or am I thinking about a different one? Or is that when the computers faced off against each other?
I can't speak to that because I think from what I was able to research here, Deep Blue won pretty much every time.
Okay.
Well, again, it's all the structure of chess masters. All I know is Deep Blue won a significant number of times after the first match took place. And
either way, it doesn't matter. He was beat.
Correct.
Regardless. So.
So then in 2005, another milestone, a Stanford robot won the DARPA Grand Challenge by driving autonomously for 131 miles along an unrehearsed desert trail. So again, we start seeing it being applied to things like autonomous cars, even back in the mid-2000s. And in February of 2011, in a Jeopardy quiz show exhibition match, IBM's new AI system, Watson, which pretty much all of us are familiar with at this point, defeated the two greatest game show champions at the time, Brad Rutter and Ken Jennings, by a significant margin. And, some interesting facts here. All in all, Deep Blue, which is the supercomputer that beat Garry Kasparov in the chess match, Deep Blue's computer was 10 million times faster than the Ferranti Mark I that was taught to play chess in 1951. So there was a computer taught to play chess in the early 50s. Deep Blue was 10 million times faster than that.
That's crazy. Just think about where we're going to be like 70 years from now.
Yeah, But, looking at all these different milestones, right, all of these feats were possible due to Moore's Law. See, I told you I'd tie it all together, which, of course, if you're in technology, you should know what Moore's Law is. But Moore's Law, again, surmises that speed and memory capacity of computers doubles every 2 years infinitely, or until we can't get any smaller, as a result of metal oxide semiconductor transistor counts on microprocessors. So again, we see all these milestones that started happening in shorter and shorter windows of time during this revival because of Moore's Law. because every 2 years we were able to fit more transistors on microprocessors, making them more energy efficient, more powerful, and more intelligent.
Mm-hmm.
So, yeah, then it was during this time and these milestones that people really started becoming familiar with AI and air quotes and some of these different things. But so what kind of was happening behind the scenes as all this was going on the main stage? Well, AI algorithms that were originally developed by AI researchers began to appear as parts of larger systems such as data mining, industrial robotics, logistics, speech recognition, banking software, medical diagnosis, and even Google search engine. So a lot of these algorithms that were actually developed during the first Renaissance in the late 60s, early 70s, and the boom in the 80s were starting to be applied to a lot of different industries during this revival. And if that work had not been done prior, maybe looking at something like Google, we wouldn't have it, which is really interesting to think about.
Mm-hmm.
Now, that's what the unfortunate part is, right? So unfortunately, the field of AI research received little or no credit for these successes in the 1990s and early 2000s, and many of AI's inventions had been reduced to the status of just another item in the tool chest of computer science versus this really fundamental and exploratory piece of technology that allowed these other things to actually come into existence in all these different industries, which is really a shame because a lot of these researchers did a lot of work, spent a lot of late nights and used a lot of brain power to come up with some of these algorithms and some of these early tools that ultimately went into things of the future, and they never got credit for it, which is...
That happens a lot.
It does. It really does. And
Steve
it's a sad culture. I don't really know what to say about it other than that because, but at least, the one positive out of that is they did put in that work. So a lot of the technologies we use today that are quote unquote AI powered do exist. Now, even during this revival period, AI still struggled with common sense knowledge and reasoning. Again, we look back to that first AI winter where that was one of the big hurdles. Well, again, still a hurdle during this revival period. And arguments as to why began to take place among some of the most prominent AI researchers, including yet again Marvin Minsky, John McCarthy, who coined the term artificial intelligence, Ray Kurzweil, one of the most well-known AI researchers and theorists, and Jeff Hawkins. So it was during this revival period they all started fighting and arguing against one another about why we could not get AI to replicate common sense knowledge and reasoning like human beings could. And of course, as we see even in 2020, we still haven't reached that point. So that was the revival period during the 90s and the 2000s.
Very cool.
Any commentary, Brett?
No, because everything you just said is just facts.
Anything specifically cool that stands out to you?
No.
All right, then.
I don't know what to say. It's like, okay, yep.
And I guess that
got
takes
revived.
I guess that takes us then to the last, the home stretch here of deep learning, cloud computing, and artificial general intelligence between 2011 to the present.
Okay, so this is cool. So you're going to be talking about deep learning, cloud computing.
Well, all the stuff that's happened over the last 9-10 years that's gotten us to the point we are at in 2020.
So we don't really realize it now because we're like living through it right now, but we're going to be looking back in the history books and seeing the turnabout of AI with cloud computing for sure, and just different other applications. Oh my God, cloud computing is amazing.
So yeah, I mean, there's no denying that over the last 10 years, some of the most prominent advancements in AI research and applications have occurred. And all of this really is due to the arrival of mass cloud computing networks that are accessible via the internet, like Amazon Web Services, Azure, Google Cloud. And it's because of these cloud computing networks, the ability to process mass amounts of data cheaply and at scale became possible. And that's always been the large hurdle with artificial intelligence, right? You need to train it on a lot of data, which gets very costly and it's very hard to scale. But with cloud computing, it becomes incredibly cheap and you can scale at will. So that is why in the last 10 years, I would actually point to cloud computing being the single most important piece of technology that has led to a lot of the developments in AI over the last 10 years.
Yeah, think of before cloud computing, when you wanted to store stuff into a database, think of it like you were on to store stuff into a box. The box is set. You can't change the box. The box is at its size forever. And if you want to get a new box, you have to buy a new box and get a bigger box. With cloud computing, you have elasticity. So when you fill up your database, it's like a rubber band. You're filling up like a rubber band, and it just expands the data, and it grows with your data. It's cool. It's really cool.
Good analogy, Brett.
Yeah.
Well, and because of this, by 2016, the market for AI-related products, hardware, and software reached more than $8 billion, actually. So we can see here that, again, specifically during this period, a lot of investment started taking place and the money started flowing back in. Advances in the field of AI known as deep learning, which are specifically known as deep neural networks, again, talking about neural networks and connectionism from the earlier time periods, drove progress and research in image and video processing, text analysis, and speech recognition. So the ability of a service like Facebook to identify human faces and images, and things like Alexa and Google Assistant that interpret and understand speech, is all because of deep learning. And us being able to finally get to a point where we can train AI models and train computers to process and interpret information like human beings. So, talking about some of these here, deep learning. What is deep learning? Deep learning is a branch of machine learning that models high-level abstractions in data using a deep graph with multiple processing layers.
Mhm.
So imagine, a singular neural network, right? A linear
Yep.
thing, and you have a couple of different nodes in that network. Well, imagine, say that network has 20 nodes in it. Well, imagine layering 15 other layers of 20 nodes on top of that first layer. So you can see how much more information you can process by doing that. And that's what we
Yep.
can do with deep learning. And during this time, state-of-the-art deep neural networks can sometimes even rival human accuracy, if not beat it entirely, in fields like computer vision and data analysis, which we saw starting to happen in the mid-2010s, and of course, very prevalent now as we head into the 2020s. So deep learning, it's again, was the birth of deep learning became possible because of cloud computing, but AI as we know it today wouldn't be AI without deep learning, if that makes sense. And then of course there's big data, which God, I hate that. I hate.
Who came up with that?
Some marketer. You
Whoever-
can ask anyone in tech, and most of us will agree we freaking hate big data because it's just a marketing term that is used in sales meetings. It's so bad. I hate it.
What should we call this type of data? I don't know.
Big data.
Big data. Jerry, you're
Just
genius.
another one of these buzzwords here. But the development of quote unquote big data capabilities in the 2010s is a primary contributor to the growth of AI as we know it today. Again, talking a bit more about cloud computing and how that fundamentally changed the game. So big data, as much of a buzzword as it has turned into, refers to a collection of data that cannot be captured, managed, and processed by conventional software tools within a certain time frame. So basically, again, it gives rise to this cloud computing concept, and it is a massive amount of decision-making, insight, and process optimization capabilities that require new processing models because we have access to all of this data. We can collect it in databases. We can sift through it in these different cloud computing networks. So big data has also been a very large contributor to machine learning, deep learning, and AI in 2020. And then to cap it all off here, of course, artificial general intelligence. So as we know, general intelligence is the ability to solve any problem presented to us rather than finding a solution to a particular problem. And AGI, artificial general intelligence, is a program which can apply intelligence to a wide variety of problems in much the same way as humans can. Now, we have not gotten there yet. There is a lot of argument in the AI community as to whether we'll get there, but that is the primary focus of modern day AI researchers and theorists, is to get us to artificial general intelligence, or that common sense knowledge and reasoning that the industry has been working towards from day one. So the interesting thing about it is with things like deep learning and cloud computing and quote unquote big data, we are getting closer to making this a reality at some point. It's just a matter of when. And we can, of course, only push AI as far as the current technology available to us, right? So, we're at certain points where we're still going to cap out on what we can do and how far we can go just based on the progress of technology at a given point in time. which again will take care of itself because of Moore's law anyhow. So,
Yep, we'll be
but
fine.
that brings us to 2020. Where we're at
And
right now, of course, where
people,
this-
it's basically the end from here. Like it's all downhill. It's rock bottom. Like
What?
2020. It's 2020. Come on.
whatever, Brett. All I'm saying is, as we enter the 2020s, this is going to be the decade of artificial intelligence. This is going to be the decade that shifts AI from being this thing that has some use cases and can do one thing really well to being applied to dozens and dozens and dozens and dozens and dozens and hundreds and thousands of different things to completely change the scope of how we process information and interpret information as we know it. And as I've been saying for a couple years now, we are going to undergo the largest transformation in what we consider to be work and the job market as we know it over the next 10 years. And people are going to get hit squaw across the face by it unless they prepare today. What?
Squaw across the face.
It's true.
Squaw across the face.
It's true. Like so many jobs that people do today at the end of in 2029, 2030 are going to no longer exist because of artificial intelligence.
Correct. But many jobs will be created because of artificial intelligence.
Well,
so
we hope. And we've seen that in the past with the Industrial Revolution and, the Bronze Age and different things before it. We've seen that happen. So we hope that'll happen with this, but we're not entirely sure. But again, if you're one of those people who thinks that, automation and AI is never going to impact my job or my career, I don't need to learn about it. Well, you're wrong, and you're going to hit squaw across the face.
why do you keep
But
saying
it does
squaw? Isn't
happen.
it square across the face?
I like saying squaw. It sounds
Okay, I'll let you say your word. Whatever. Maybe I'm wrong. I don't know.
So the best thing you can do right now is learn about it and figure out how you can keep yourself valuable as this happens. And as I've talked about in prior podcasts with different guests, everything that we've seen in the last several months with the pandemic was going to happen regardless. This change in how we conduct work, remote working, all this different stuff. I've been saying for the last 3 years as I've given some of my talks that this is going to happen. It was supposed to happen over the course of 10 to 15 years. Now it just happened in several months. So things got sped up quite a bit, which is both good and bad, right? Good in the sense that we're going to be making a lot more progress a lot quicker than we would have had the pandemic not happened, but bad in the sense that it blindsided everybody because nobody was prepared for it. And now we're dealing with this unemployment crush like anything we've ever seen.
Yeah, it's not
And
good.
there's nowhere to stick people.
I think it would have been better to easily gradually go into it.
Correct. Now, people still would have been blindsided, don't get me wrong,
Well,
but it would have been a
yeah.
lot less of a blow than it has been the last several months because a lot of these jobs probably aren't coming back. And it's not even just because they may not be available, it's because throughout this process and having to distribute workforces, enterprise is looking at this opportunity to analyze, is there something that we can automate here? Is there an intelligent program that's quote unquote AI powered that we can deploy to do the same work that this one person did? I mean, all that thinking is starting to happen now because nobody thought that the entire world of work could be distributed. So if technology can allow us to do that, what else can it do?
Yeah,
And that's what people are thinking about right now.
Past couple of decades, we've been worried about jobs going away because they're being outsourced outside the country. Now they're going to be outsourced to the cloud.
Yeah, exactly.
Bye-bye.
So, and not to get political on this podcast, but the folks who are trying to be like, we need to keep the jobs, we need to keep the old jobs, we need to keep the old jobs. Well, no, because regardless whether you want to keep the old jobs, they're going to be automated at some point. So the only thing that you can really do is prepare for the future and figure out how you're going to keep people employed and keep their skill set up to match what's needed in the new marketplace. But
Correct.
hey, I'm just a crazy person.
If you constantly hold on to the, let's just say 1,000 old jobs, you potentially could be leaving out a potential 5,000 new jobs.
Correct. Yep.
So
that's perfect, Brett.
Sometimes leaving the past behind is good.
But again, it's hard to convince a lot of people of that. But we won't get into all that. But anyhow, that wraps up the history of artificial intelligence. Part 2 has come to an end. So hopefully now you have a better idea of where we were and how we got to where we are now. This is actually really fun to learn about and research, to be quite honest.
Yeah, it is. It is. It's fun.
And hopefully for those of you listening, it puts a lot of this into perspective for you to show that history does matter. Because if things weren't done in history, we wouldn't be where we're at today. So
we need to know history so we don't repeat history.
you know, we seem to have a really good habit of repeating history.
Oh yeah, we do.
Sorry.
Nobody
I can't help myself.
Nobody learns about history these days.
Anyhow, that wraps this episode up. So, Brett, you have anything else you'd like to share before we sign off here?
No, I think we did a full round encompassing of everything in AI and the history of it, and I think we did a good job here.
Good. Well,
We went over a lot of topics.
we did. Well, thank you all again for being listeners of the Artificial Podcasters, being listeners of the Artificial Podcasters, silly Nick, for being listeners of the Artificial Podcast, as I like to refer to you all as Artificial Podcasters. Brett and I, wouldn't be doing this week in and week out if it wasn't for everybody who listens to the podcast and the feedback that you've given us about how much you enjoy learning about all this and the people we bring on the show. And if it wasn't for you all, we wouldn't be doing this week in and week out. So as I always say, thank you very, very much for all your support. And hopefully we'll continue to grow this and help empower more people by helping them learn about these really incredible technologies.
You were on a roll there.
I did.
I couldn't even interrupt.
No. Anything you'd like to say, Brett?
I was just gonna be funny and be stupid and say we probably would still be doing this, but it's great for the support. Thank you.
Oh, Brett.
God damn.
All right. See y'all later.
See you later.
Artificial
Intelligence.
voice recognition. Machine learning.
Robotics.
You've been listening to the Artificial Podcast with your host, Nick Myers.
Nick Myers.
To stay up to date with all our latest episodes, you can subscribe on Apple Podcasts, Spotify, Stitcher, and Google Podcasts. To learn more about how your organization can benefit by unlocking the power of AI and voice, visit www.redfox-ai.com. Until next time.